and I'm sure additional folks will trickle in. And also, we're gonna send out the recording afterward. So with that, I'll jump right in. So starting right off, welcome everyone. Thanks for joining us today. I wanted to highlight a few items as we get started. So for attendees on today's webinar, your camera is going to be turned off and you'll be muted. If you do have questions during the presentation, we ask that you use the Q&A tab at the bottom of your Zoom screen and you can enter questions there. Let me just make sure that that is up and running. I believe it is. And a Q&A session will follow the main conversation. We'll talk through the agenda in just a second and we'll address your questions at that time. After today's session, we are recording today's presentation and we'll make it available when it's ready. And if you hear or see something from our panelists today that you'd like more information about, feel free to send us an email. We can set up a one-on-one or call to discuss some more. So in terms of intros, my name is Amrit. I'm the CEO and co-founder of Axiom Cloud. I've been helping grocery stores and large commercial refrigerated facilities optimize refrigeration for 10 years. Refrigeration is a massive climate opportunity and financial opportunity. And it's a really overlooked and underserved category as well. So we started this company, Axiom Cloud, a few years ago to solve the biggest problems plaguing the space using software and automation. So we're really excited today to be presenting alongside folks with HelloFresh, namely Danny, William Wise, who goes by Danny, and Benjamin Spoon, who goes by Spoon, and then also Henry Papa, who is my colleague at Axiom. So why don't we go from left to right? Danny, you want to give a really quick intro, your role at HelloFresh, kind of what you spend your days doing?
Sure. So I am currently a senior regional manager for our Factor segment, previously reliability program manager for HelloFresh US.
Awesome. Yeah, thanks for joining us. And then Henry.
Yep, I'm Henry Papa. I'm the lead project manager here at Axiom. So my day-to-day is surrounding customer success. Now that our applications and software is deployed to a customer facility, how do we bring that customer set value?
And Spoon.
Yeah, my name is Benjamin Spoon. I'm the Associate Program Manager of Refrigeration here for HelloFresh network-wide.
Very good. Yeah, we're really excited to be in conversation with you guys today. So I also wanted to highlight that, this is not meant to be an advertisement for Axiom. This is really meant to be, this is part of a quarterly webinar series that Axiom Cloud does. And the idea is to highlight the role that data and cloud and analytics and that entire playbook can play in helping to really modernize the space that we're in. And the space that I'm talking about is the cold chain. So buildings that use refrigeration and consume large amounts of power and maintenance and have major sustainability impacts because of these refrigeration assets that they operate at their facilities. And so, yeah, we want to be the evangelists for data and cloud and software as a tool to really help transform the space regarding refrigeration. So with that, let's talk about our agenda. So we'll start with a quick project overview. And then we'll talk about what predictive maintenance looks like for HelloFresh, and we'll go through specific examples and case studies. And in three key areas, really: continuous energy commissioning, refrigerant charge management, so that means early leak detection, and then failure prediction that's actionable. After that, we're going to talk about how HelloFresh generated new revenue via demand response, again, using software and data and cloud and automation. And finally, we'll go into Q&A. And after that, we'll be towards the top of the hour and we can pause there. So let's start with the project overview. Henry, do you want to discuss this one?
Sure, I could kick this off. So an overview of this project, we were focused on one of the production facilities here in the US for HelloFresh. This was a warehouse that was about 100,000 square feet, which included both fresh and frozen areas. So overall, the goals that we had for this specific project was, number one, to reduce CO2 emission and food waste, reduce energy and maintenance costs. We wanted to also generate a new revenue stream for HelloFresh, that being demand response incentives, and then to make refrigeration data accessible and actionable across the HelloFresh company. So the apps that were subscribed to were our Facilities Analyzer app, as well as our virtual battery. So some key results that we had around 71,000 in measurable value in the first 6 months. And now we're expanding and deploying applications throughout some other facilities in the US. Now, one question I do have here, which would be, Danny, if you could elaborate, why did we choose these goals specifically for this project?
Well, mostly, so this initiative was kind of spearheaded by our sustainability team with the goal to, as you say, reduce CO2 emissions. So as a global company, we are very, very focused on our carbon footprint. We have a lot of very aggressive goals to be more, increasingly more of a green company. So that kind of started the ball rolling and also gave us the added benefit of the facilities analyzer and, just being able to have some visibility over general system health as a whole.
And in terms of the 71K in the first 6 months, how are you feeling about that? Do you feel like that's, is that meeting expectations? Is that kind of going, is that conservative? Is that aggressive?
I think that that's pretty conservative because I think that this 71 is based mostly off of one particular incident. So I think that that's a very conservative number for what we've seen as far as value.
Okay. Yeah, we'll talk more about that one specific incident, which I think is actually excluded from this number, Danny.
Oh, okay, great.
So this would be the everything else number. But yeah, we'll chat more about that. Super helpful. All right, let's keep going here. So we've done the project overview. Now let's talk about predictive maintenance in the real world with a focus on the first of 3 categories, which is continuous energy commissioning. And Henry, you want to talk us through this?
Sure, absolutely. So, as we just discussed, a lot of the primary goals of this project were to reduce energy consumption and greenhouse gas emissions, which also come from reducing energy consumption as well. So one of the first predictive maintenance topics that we discuss and study at all of the facilities that we manage is continuous energy commissioning. So what it is, it's adjusting set points or changing control algorithms to reduce that energy spend, and not just instantaneous. This would be for an ongoing basis. So how this works, again, using a digital twin, what we're trying to do is compare actual system level performance to what we determine is ideal. We want to diagnose the root cause of any deviations or find opportunities to help improve the system performance using these unsupervised ML models. And so why we consider this ongoing is because this term called backsliding. So backsliding happens constantly, and meaning, we make a change, but then we again start to deviate from this ideal state. And this could be for several different reasons. Some of the primary ones, seasonality. In the refrigeration industry, different seasons, different ambient conditions are going to affect the way our systems operate. Some other things specific to supermarkets, it could be temporary merchandising changes. So, we just passed Thanksgiving, changing the product that are in specific cases could change the way systems perform. And then, I'm sure Spoon and Danny could speak to this, but, some miscommunication or misaligned technicians that are just making changes to alleviate a temporary problem, but not really thinking about the implications down the line.
The Band-Aid fix. So Danny, given that your primary role is really maintenance and uptime and reliability, has continuous energy commissioning been useful for you, even though energy really isn't often top of mind for you?
I think it's been beneficial to both our sustainability team and our maintenance personnel because it does kind of contribute to the overall health of the system, especially when we're controlling like cycle times and things like that. We do get the added benefit on top of the energy savings to be able to kind of control, how our systems are operating.
Makes sense. And Spoon, have you seen some examples of, these recurring energy issues? You solve them once and then they pop back up again a few weeks or a few months later?
Yeah, absolutely. These happen a lot, these energy issues, especially the seasonal ones. it's something we always have to stay on top of. This kind of technology really helps us to see those changes in either product or seasons and helps us be in front of it instead of reactive. You could be more proactive with this information.
Nice. And for anyone wondering, bionic jellyfish are not a part of our process here. This is a pretty over the top image, but at least grabs attention. Yeah, no bionic jellyfish. Cool. All right, let's go to the second category here, which is, or actually, no, this is a case study for continuous energy commissioning.
Yeah,
So talk through this one.
absolutely. So this is one of the first things we actually analyzed at the said facility, which is what set points can we analyze and determine if there's a better set point. Is there some set point optimization we could do? And one thing that we saw at this facility specifically is that the head pressure was set rather high comparative to the ambient conditions of the facility. And I mean, this is something that we see commonly, which is, this is the set point that we've always used. We've never questioned it. And we could get into some questions there for you specifically, Spoon. But, how it was fixed was that HelloFresh authorized Axiom to lower this head pressure using software. We ran through various simulations and models to determine what would be an optimal set point, as well as really using historic data, forecasted out what the energy savings would be for the upcoming year by reducing this head pressure set point. So by doing this, why this matters, the compressor doesn't have to work as hard. So by reducing either head pressure or suction pressure, we're reducing the energy consumption of the compressor, as well as we're reducing the wear on the compressors by reducing that head pressure set point. And so what we determined here is by reducing this head pressure set point, we would reduce energy bills by about $23,000 a year. And we would reduce the scope 2 emissions by, roughly 95 tons of CO2 a year. So really impactful there. But again, one thing we just mentioned is backsliding. This is something that is ongoing. Although we make this change, this is something that still has to be analyzed throughout different seasons throughout the year to ensure we don't have any backsliding effects or negative effects by reducing these set points.
Yeah, and after, I think, Henry, correct me if I'm wrong, but after we implemented this, it did get reverted back to its original set point.
That's correct.
And so, that it required some additional conversations with other stakeholders on the maintenance side, who are, the local folks, to ultimately really make this one stick. And now it is sticking. And yeah, we're really happy with the results. So yeah, Danny, beyond the energy impacts, does this type of anomaly improve maintenance reliability also? I think Henry alluded to this briefly.
Yeah, I would say so for sure. As you mentioned earlier, it reduces the amount of stress we're putting on the system, and gives us kind of the ability through this software to make informed decisions based on real data.
Cool. And then Spoon, rules of thumb. That was something that we chatted a lot about when we were kind of preparing for today's discussion. Can you talk a little bit about having to fight these rules of thumb among technicians and why this is such a big problem, and kind of just talk about rules of thumb a little bit and how it's a barrier?
Sure. In the world of refrigeration, we're all taught things as we learn the trade. They become rules of thumb, just standard operating procedure, if you will, for guys that are working on refrigeration. Hey, this line's cold, or the head pressure should be this. But none of that was really analytically driven in the past. Now that we have this technology, we should really refer to it, because there's so many differentiating factors between systems that should really help us to guide our decisions, instead of just grabbing a line and seeing if it's cold, or just making a judgment call based on a different system you may have worked on. So I think this really kind of eliminates doing something because that's just the way you've always done it. This is supposed to change hearts and minds and move us into a way to perform our duties more analytically driven, with the end result in mind, rather than just fixing it for today.
Yeah, I guess when you're thinking about doing things the way doing things a certain way because that's the way it's always been done. I guess by definition, these rules of thumb have to be really conservative, because ultimately, you got to deal with every climate zone. You have to deal with every part of the year, the hottest days and the coldest days. You have to deal with facilities that are old versus new, et cetera. And so ultimately that makes these rules of thumb just extremely conservative, right? To manage that, all the edge cases of all those different types of scenarios.
Yeah, right. That's correct. That's the problem, is that there's not enough information there when you're making an adjustment or a judgment call based on a rule of thumb. A lot of times you're not weighing all the factors. So this really brings all the different factors to the forefront and helps you make an educated decision using analytics and the end result ultimately at the forefront of why we're doing something.
Makes sense. All right, let's go to our second topic area, which is predictive maintenance in the real world with a focus on refrigerant charge management. So I can give this overview. Basically, the idea here is that in facilities today that have large refrigeration assets, there is not typically a great way to measure or quantify how much refrigerant is in that system at any given moment in time. Because refrigerant moves around all the time, it changes based on operating conditions. You can measure the liquid level of refrigerant in the receiver, for example. That's a picture of a receiver shown right there in the slide. But that's only a small part of the overall story, because refrigerant can pool up in all kinds of different places too. And so the bottom line is that the way that I think about this industry is it's kind of like driving down the road in your car and you don't have a gas needle in your car. And so everything's fine until suddenly you run out of gas, and then you're on the side of the road and it's a huge emergency. And so basically the opportunity here using data and analytics and advanced modeling and cloud is to add the digital gas needle to monitor refrigerant level trends, detect leak fast, and really identify conditions that are indicative of too much charge or too little charge in that system. And so it's a big opportunity. And the cool part about this is that we're using existing sensor data. So we're not adding expensive new sensors. In fact, what we're able to do at Axiom is it's really industry leading, is our understanding, in that we can ballpark refrigerant levels and detect trends in relative refrigerant levels over time, even if there are not receiver level sensors present. And so we're really excited to transform the industry using data, because a lot of folks don't have analog refrigerant level sensors, or in some cases don't have any sensors at all, even a digital switch. And so that makes it really difficult to understand what's going on and to really get ahead of refrigerant leaks before it's too late, before you've dumped thousands of pounds of gas, before you're in a critical situation where the system can't run anymore. So yeah, why it's useful: we can catch leaks earlier, we can reduce downtime, reduce greenhouse gas emissions, scope 1. And then another really important piece is that Axiom is listed as a automatic leak detection software with CARB and with the EPA. And so what that means is that by installing a solution such as Axiom, there's all kinds of other solutions available too. You can eliminate manual leak checks that are required legally on a monthly or quarterly basis. And so just an immediate source of value that's available by eliminating all that technician time and those manual checks. So let's get into a specific example here with HelloFresh. So in this case, we were essentially, I guess, Danny, do you want to talk through this one, or Henry?
Yeah, sure. I could speak to this. This particular incident, we had our case temperatures were out of spec and had been for a bit. Our contractor proposed adding at least 2,000 pounds plus of refrigerant. But however, after looking at the data and the anomaly reports that Axiom issued, we found out that the root cause was most likely the subcooler and not a low charge. So that definitely gave us the information to come back to the vendor and question, their troubleshooting, their diagnostic steps, and really gave us some insight on where they were incorrect. So, as opposed to dumping a lot of gas in the system that wasn't required and would not have solved the problem. We were able to get to the actual root cause and repair it that way at a much, much lower cost to the company.
And actually achieve the desired outcome of, achieving space temperatures again. Adding gas probably wouldn't have done that.
Correct.
Cool. So yeah, this is one that we struggle a little bit on exactly how to quantify, but we ultimately decided to take the conservative route and not include that in total project savings. So this is an additional $71,000 that's was avoided essentially in HelloFresh costs just through this one incident. So really powerful use of data, in order to kind of push back on the contractor. I guess Danny, one thing you said yesterday really resonated with me, which was, you're talking about the contractor's reasoning for making this recommendation and, why they thought this was the right idea. Do you want to comment on that?
Yeah, so when I questioned them and asked them for what data they were using to come up with, a corrective action of adding refrigerant, basically their comments were, well, when you've been doing it this long, you just kind of know, which speaks to that rule of thumb sort of thing that definitely didn't sit right with us as a maintenance team, where we were really expecting a walkthrough of what the diagnostic steps they took were and how they got to their recommendation to add, a literal ton of gas to this system. But yeah, they weren't able to quantify exactly how they got to their recommendation beyond just kind of a feeling, right? Just kind of that rule of thumb where if this, then add gas, which is not, clearly was not the correct move.
Yeah. And then just to put a finer point on this, so, if Axiom wasn't here and, providing some of this data, what do you think would have happened ultimately in this situation?
Honestly, the local site leader would have probably okayed this job, and we would have dumped a lot of refrigerant in this system and not gotten the end result. So it would have been a huge waste of time, money, and could potentially have caused more damage to the system.
Makes sense. Okay. And so I guess that kind of feeds into, what did we actually fix here to solve the issue? Henry, you want to talk through this?
Yeah. So as we were just mentioning, I mean, really the impetus of what we were looking at for refrigerant leaks was we were not maintaining some space temperatures, and we wanted to determine what was causing that. So using the data that we had available through the platform that HelloFresh had, we looked at several things. And then one thing we need to consider is what other symptoms are we seeing? What other traces are available that are indicating if it was a refrigerant leak. But what we saw was that really there is this lack of subcooling. So our liquid temperatures were maintaining relatively high compared to at least OAT displayed in this picture. So we identified that there was a space temperature issue, and it wasn't caused by low refrigerant. We could see that was maintaining throughout the rest of the system. Our condensers were operating fine. Where this came from was the subcooler. We didn't have capacity. And so really the suggested actions here were very, simple, meaning, inspect your TXV and solenoid valve at your subcooler, make adjustments or replace as necessary. And then once that's done is recommission that TXV on the subcooler to the correct superheat setting. And so why I say and think this really matters, although subcoolers are part of PM work, sometimes it's not obvious. Sometimes it's a little bit subjective. Maybe it's the technician's level of experience. Maybe it's the time of day that they're inspecting the subcooler. But it could be not obvious that the problem is there. And by using this data analytics, by just unlocking historical data that you could trend pretty easily, it's very easy to see that, the subcooler is not meeting its set point. And, as we know, subcoolers are really giving us that boost in capacity needed to maintain space temperatures.
Spoon, you were mentioning that subcoolers are part of PMs. Is that right?
They can be, but PMs are done periodically, obviously. So a lot of times during a PM, you're just catching capturing a single moment in time. So if you're not really going back and looking at what possibly a different technician captured in that moment of time they did the PM, and really trying to drive home what that information means over an elongated period of time, you can see that this one here is over a couple, 3 months, and you can't really decipher that the subcooler is having a problem unless you're intentionally going in there looking for that. Because on a PM, you're more or less just checking operation and less digging in and trying to see what this means during this month's maintenance compared to last month's maintenance. So to have it out graphed like this, it really helps you understand wholly what that subcooler was doing. And I don't think you'd be able to capture that by doing a PM.
So during a PM, the technician is going to be doing those more invasive manual checks of, attaching gauge sets to Schrader ports and things like that, and measuring temperatures, measuring pressures physically, and then, basically writing things down with pencil and paper. Is that right?
Yeah, that's correct. But again, if you're not referencing what possibly another tech did on a different maintenance in a different quarter or month, then you don't really know if you're looking at right or not. You're just more or less taking down information.
So looking at the trend over time, comparing it to other relevant data sets, like in this case, outdoor air temperature, that's kind of what's really telling the story and shining the spotlight on this pretty non-obvious issue. It's surprising because something is, like a subcooler can be the culprit for such a major temperature concern, or something as, as critical as temperature. But yeah, it's really tough to see. So yeah, thanks for explaining that.
Yeah, and can you also elaborate on, I know we mentioned this yesterday, which is, looking at data is less invasive. So would you mind elaborating on that? Maybe
Sure.
Spoon, I'll leave that up to you.
Yeah, sure. Anytime we could keep a closed system closed is going to be beneficial, because anytime you open a system to just do some checks, not really understanding what the outcome might be, you introduce a lot of potential harm to the system. So anytime we could keep it closed and just take analytical data into consideration on whether or not we should open a system that's closed or sealed, or if we should do this invasive procedure or not, that if the data really backs it up, then it makes a ton of sense, because a lot of times we do perform these procedures when they weren't necessarily justifiable.
Yep. Yeah, makes sense. Okay. And this is a really good segue into kind of the final section in this segment, which is predictive maintenance in the real world with a focus on actual or actionable failure prediction. I guess, talking about the subcooler really was an example of this. So at a high level, what this is identifying problems before those reactive alarms happen, before you're running into a critical temperature issue, diagnosing the root cause of the issue, solving those problems using software. And if it's not possible to solve during software, which it only is a portion of the time, identifying the location of the problem, and then batching and triaging that issue to really help streamline technicians' work and help to streamline those truck rolls. So the whole idea is, take a population of 10 problems, and first of all, eliminate 3 of them using software, make them disappear, no humans involved. And for the remaining 7, basically identify, how urgent are each one of these issues, and then batch and triage such that that can all be, put into 1 or 2 truck rolls where the technician knows exactly where each problem is, how to solve it before they even show up on site. And then they know, hey, I need to go, within the next 3 days to solve these 3 problems, within the next 2 weeks to solve these other 4 problems, that sort of thing. So how this all works, there's just an incredible wealth of data from existing sensors that's already on site, and relative changes in performance and system performance over time is really what triggers the unsupervised machine learning models in many cases to identify that, hey, this is trending in the wrong direction, or these 2 or 3 different traces are trending in the wrong direction, which is indicative of a big problem. And the really cool thing about machine learning is that in some cases, we're programming in specific failure modes to help the machine learning identify a specific kind of problem. But in other cases, the machine learning is identifying things that we didn't even teach it, and it's teaching us about various problems. And it's helping to identify things that our humans didn't even see. So it's really cool to start to marry together the technology and the machine learning models with the really smart folks in our team, like Henry. And so, yeah, the idea here is using software to solve those problems directly or translate findings into really highly actionable and clear anomalies, again, to streamline technicians' workflow and take as much thinking out of their job as possible, increase the chance of success during their first visit. So why is this useful? Prevent a lot of failures from occurring entirely, reduce emergency repairs with proactive repairs. So in other words, rather than doing something in the middle of the night and overnighting parts from across the country, do it in a really orderly fashion during regular work hours, no overtime, that sort of thing. And then reducing unplanned downtime and saving money ultimately. So one example on this is oil filter replacement. This is a very, very simple one. Henry, you want to talk through this one?
Sure. Yeah. This is something that's becoming more and more popular in the industry, is looking at differentials across filter elements to know when they're being plugged up or ready for replacement. So in July, we indicated that this oil filter on a specific compressor needed to be replaced to prevent compressor damage. So again, the suggested action items here is just replace the oil while the compressor is offline. This also enables technicians to do any routine PM work on the said compressor, to restart the compressor and system, confirm that the differential pressure is within those acceptable limits here. And so why this matters, we talk about different types of maintenance. We talk about the proactive maintenance. We talk about reactive maintenance, but here this would indicate, more the right time maintenance. So why is it the right time? Because again, of the seasonality component, knowing that the summertime is coming up, the peak temperatures, we want to get ahead of this before we're in a very high load scenario where we can't afford to have a compressor go down. So this also matters because of course, it protects the compressor. High differential across an oil filter indicates several things. One of that being there's debris contamination inside of your system, which could be damaging not only the compressor, but other components that depend on the refrigerant as well as the oil itself.
This could be a canary in the coal mine.
Exactly.
Spoon, can you talk about PMs and trust but verify? Was a phrase I heard you use yesterday.
Sure. So first, on the topic of PMs, this really helps you narrow down. I'll speak to the right time PM. Most of the PMs that we've done in refrigeration have always been a scheduled thing. So you do it quarterly or monthly or yearly, but you may be missing, or the system may require something that needs to be changed. In this case, it was an oil filter on a compressor that would have gone overlooked because the PM wasn't scheduled for 3 or 4 more months. So the damage would have just continued to go on, and possibly could have experienced compressor failure, would have been worst case scenario, but obviously other damage could have been done to other components. Pardon me, I'm kind of out in a bullpen here, so I got a lot of traffic going on around.
No worries.
And I lost my train there, Emery. What was the second question?
Yeah, just thinking about those the PMs, and I guess, have you been in a situation where you're really questioning, like, was this PM done at all, or was it done correctly, and kind of trust but verify?
Sure, yeah, that's a great point. So a lot of times we have vendors out to do maintenance or repairs, and you're not really sure. Danny spoke about this earlier with the vendor with the refrigerant. You don't really understand why they're coming to the conclusion they are, or they said that something has been repaired and you're not quite sure that it was, or you have any doubts. You could always go to this data. I think it's an amazing opportunity to trust but verify. Okay, the vendor says they've changed those oil filters. Now we can see in real time, hey, our differential has improved. It looks like the oil filters were changed. So the vendor is charging me for this job, and I feel confident in paying the invoice and understanding that my system's in good operation.
Makes sense. Yeah, Danny, you were talking also about kind of the ability to verify remotely, kind of right away when a job's done, before the invoice is paid even. You want to talk about that at all?
Yeah, absolutely. Just to kind of touch on what Spoon was saying, yeah, having the opportunity to see real-time metrics on how the system's operating. If, because I'm sure a lot of folks can speak to the fact that they have had some issues maybe with some vendors in the past where you're looking at an invoice and looking at everything that they're billing for, but your confidence level based on space temps or other system performance metrics is pretty low, right? So this gives you an opportunity to look and verify that the work was done, and gives you an opportunity to catch when maybe something didn't get done correctly. Maybe there were 6 filter changes that needed to happen, but somehow they only got to 5, right? So this allows you to pinpoint, what didn't get done based on the metrics from how the system's operating, and gives you the opportunity to kind of catch those things. More importantly than before paying the invoice, you can catch it before a system failure.
Before you see some really negative downstream effects.
Absolutely.
Makes sense. All right, and the last stop before Q&A is talking about demand response. So basically, another opportunity here that HelloFresh has taken advantage of is basically lowering the power demand of its facility, of its warehouse/production facility upon request from the utility. So a day ahead notice, they're participating in a demand response program, which means that they help the grid remain stable by reducing demand when requested by the utility. And so that has a lot of economic value. The way that that's working for HelloFresh, and for a lot of other grocery stores and cold storage facilities throughout North America at this point, is using the frozen goods in that facility as a thermal battery. So the idea is basically drive the temperature of those goods down by a few degrees and pre-cool them, and then load shed by doing the opposite. Basically, during those periods when the utility requests a reduction in demand, you can turn off refrigeration compressors or modulate them down substantially to reduce the building's energy consumption on demand for a couple of hours, and then get paid for it by the utility. So yeah, getting paid by the utility is really the key benefit. And also there's the secondary benefit of contributing to grid stability. And the reason that this really resonates with me, I'll go on a soapbox here for a second, is that the more flexible, intelligent, and resilient the electricity grid is, that means that it can basically accept larger amounts or higher penetration levels of intermittent solar, intermittent wind, intermittent electric car charging. So in other words, it helps us to really accelerate this transition to a clean energy future if the grid is more flexible, more intelligent, more resilient. And so, that's what lithium-ion batteries do. They really help the grid become more robust. And that's what demand response programs do. That's what folks like Axiom are hoping to do in this space as well, related to cold storage and retail grocery. To make them more intelligent, more flexible, prepare us for that clean energy future. All right, I'm getting off my soapbox now. Let's talk about a specific example at HelloFresh here. So what we're looking at is on the top is suction pressures and space temperatures. And on the bottom is power consumption of the facility and compressor run statuses. And so what you can see is that HelloFresh in this example participated in a demand response event by pre-cooling and load shedding the low temperature refrigeration, so the frozen portions of its facility. The effect on building power was that during pre-cool, the building power increased by about 75 kilowatts for a few hours there. Looks like about 3 hours or so. And then during load shed, the building power decreased by 150 kilowatts for 2 hours during that load shed event that was called by the utility company. And so obviously that has really large financial benefits in terms of payments from the utility to HelloFresh. And this facility has a lot of thermal mass. And so what that means is that there's a really negligible change in space temperatures over that 2-hour period. To put a finer point on it, HelloFresh literally has pallets of gel packs. Or what is that what you call them, the gel packs?
Yeah.
So I guess this is kind of the best case scenario in that you have, enormous kind of thermal batteries sitting inside the facility, as well as the thermal mass of the facility, the racking, the other products, the air, everything else in that facility is also a thermal battery. But long story short, enormous amount of thermal mass that enabled us to provide a lot of load shed capacity without having really any meaningful effect on product temperature over a 2-hour period. Yeah, any comments on this, Spoon or Danny?
No, I think you kind of hit the nail on the head. So we didn't see any frozen product, gel packs, anything like that out of temperature spec throughout this event. So it was, in our eyes, pretty successful.
Awesome. All right. So that's the end of our formal slides. We want to now devote a couple of minutes to Q&A. So if you haven't already, open up your little Q&A bubble and ask some questions. Make sure that this is, yep. Yeah, I see some questions coming in already. Awesome. So keep those questions coming. So yeah, right off the bat, okay, wow, this one is pointed. How has Axiom been as a vendor? Spoon and Danny. Thank you, audience, for that question. I'm bracing myself here.
No, I can speak to that. I would say that Axiom's been a very good partner for us so far. So we've asked for a couple changes to be made. We are working with Axiom to integrate the Axiom platform into our future SCADA applications. So as far as a partner, Axiom has been really great to work with. They've been, very free with information, very quick to offer changes on their end that might help, make integration a little bit easier for us. So overall, they've been very responsive to any requests that we've had, and have pretty much always been available if we've got questions, comments, concerns, and we work through them as a team.
Awesome. Appreciate that feedback. I guess, Spoon, any thoughts there? Or go to the next question.
You guys rock.
Love it. All right. Are you seeing the ROI that you had hoped for? Are these predictive maintenance savings real?
Yeah, I can attest to it. When we compiled all the information off of our pilot to go to a network-wide implementation, vetting the ROI was a big part of that, right? So if I'm going to ask for, a good chunk of money to bring a system to the whole network, I've got to be able to kind of back that up with numbers. And I was able to do that based on the predictive maintenance opportunities that we've had, the energy savings. Realistically, kind of, I think part of what we put together, the energy savings alone basically paid for the subscription for Axiom. So we were already in a positive ROI there. So all of the maintenance benefits were kind of like on top of that. So we were able to benefit in both realms there.
Awesome. Actually, this is a follow-up question from me, Danny. When you're thinking about quantifying those maintenance benefits, how do you assign value to those, and how do you report that internally and get buy-in for that?
So definitely we only brought up the one example, of the, proposed refrigerant ad. That was definitely a huge win for us. We avoided spending, tens of thousands of dollars on unnecessary repairs. But that was only kind of the one example that we brought up on this call. There were several other anomaly reports that the system automatically generated that allowed us to get ahead of something where if we had not done so, we would have experienced a component failure that would have been definitely detrimental to our business, right? Regardless of the money spent, it would have caused some headaches for space temps not being right and, potential loss of product, things like that. So yeah, I think it's a valuable tool.
Makes sense. Okay. Thank you. All right. Question from the audience. So you mentioned the digital twin. Are you running physical models of the refrigerant system or a surrogate model? Is this real time?
Yep, I could take this one on, right?
Awesome. Thanks, Henry.
Yeah, so that's a great question. And so we're actually doing both. So we do have a thermodynamic based model that we run in real time. Again, that's how we get to our ideal state and compare it to the actual state. And then we also use machine learning models, which are running what I would say not exactly real time, more like ad hoc, which is trying to forecast the expected performance of the system based on its historical performance. So in short, both.
Awesome. So yeah, if there's a follow-up question there, feel free to type it in. Let's go to the next one here. Do you use Axiom to help police maintenance contractors?
Yes, very much on, as we mentioned, Dot, our pilot program, Axiom gave us a lot of insight over how our vendor was actually performing and, gave us the data to ask pointed questions that ultimately ended up in us making smarter decisions on what we were going to do as far as maintenance and repairs.
Awesome. Looks like we're running low on questions. If other folks do have questions, now's the time. Type them in. Yeah, anything else you want to add, Henry, at this point, or should we wrap things up?
I don't think I have anything to add.
Okay. Yeah. Anything, Danny or Spoon, you guys want to talk about?
I mean, I think we've pretty well covered everything. If there's no more questions from the group, I think I'm pretty satisfied.
Awesome. Well, let's give 10 minutes back. So yeah, I really want to thank Danny and Spoon for participating. It's been a really great conversation. We're really excited about the partnership. Huge amount of opportunity to do some big things together and throughout North America with you guys in the coming months here. So we're super excited about next steps. And for all our participants and attendees, thank you for coming and spending an hour with us this morning. I hope that we changed your thinking on at least one small nuanced topic related to refrigeration and data and how to optimize things and prepare us for this next phase of the industry. So the recording will be emailed out to all registrants when it's available. Feel free to reach out to any of us if you have other questions or interested in learning more. A great place to start is emailing me or sales@axiomcloud.ai regarding Axiom stuff. And then, yeah, Danny or Spoon, if you guys want to get in touch with them and you don't have contact info, let us know. We'd be happy to put you in touch with their permission, of course. So thanks all so much for participating. And with that, let's call it a day.
Awesome. Thanks, team.
Awesome.
Thanks.
Thanks, everybody. Have a great day.
Have a good one.